In this recording, we're going to learn about additional graphs of polar equations, specifically circles. So I'd like you to do a little exploration here. I'd like you to visit this webpage, tinyurl.com/jdpolargraphs. I'll give you a second to get set up with that. Okay, so hopefully you got to that website, and if you get to that website, you should see something that looks like this. What I would like you to do is jot down these questions on your notebook paper so that you can discover the answers. So set up your notebook paper, and we're going to look for the characteristics of an equation of the form r equals m cosine theta. And I want you to play with the value of m a little bit using the slider that I've set up, and use positive and negative values and determine what is the relationship between m and the radius of the circle. Find out what line is the circle tangent to all the time. Tangent means it brushes right up against it, does not cross it, it just touches it. What line is the circle center always on? And then determine what happens when m is positive versus negative compared to the pole. Okay, so after you've got that set up, we can explore this a little bit. Okay, so hopefully you visited that webpage and you're at this Desmos exploration. First thing I want you to do is hide a couple of the functions so we don't get distracted. I've got 3 functions on here, red, green, and purple. So if you just click on the green function here, it hides it, turns it off, and the same for the purple here. I'm just focusing on the red circle, and I want you to play with the m slider a little bit, positive and negative values. And after having done that a little bit, go ahead and answer these questions that you wrote down. And if you need to revisit the Desmos to try to answer them again, come on back. All right, give you a little work time, play the recording when you're ready. Okay, so hopefully you've had a chance to work all these out. If not, please get back to it. So when you slid out the value of m to different values, m being 6, you can see that the radius is half of that. And even when I take it over to -6, for example, the radius is still half of the absolute value of -6. Okay, so we'll make a note of that. Circle is always tangent to what line? Well, tangent means it brushes right up against it. So that's the line where theta equals 90 degrees. And the center of the circle, no matter what I do to m, the center of the circle is always on this horizontal line, which is called the polar axis. And okay, when m is positive and when m is negative, what side of the pole is the circle on? Okay, so hopefully you picked up it's to the right if it's positive, left if it's negative. All right, so let's talk about how we're going to get one of these graphs on your graph paper. We're going to set up your calculator in the correct mode so that you can graph this on a piece of graphing paper. Okay, so the first thing is we're going to go into mode. We're going to make sure you're in degree mode, and we're going to make sure your 5th line here, instead of function, is set to polar. All right, so I'm going to take a screenshot here. The second thing you're going to do is format. So you're going to hit second zoom, and you're going to move on the top line from rectangular graphing coordinates to polar graphing coordinates, and then hit enter. All right, so we'll take another screenshot of that. Next, we will set up our window. So you're going to press window, which is right here. And for window, let me move this thing out of the way. We're going to have our theta go from 0 to 360. We're dealing with degrees. And the step can be 10 degrees, right? That just matches our graphing paper, right? We've got 0 to 360, 10-degree increments. So no shockers there. For our x min and x max, well, because the coefficient of cosine theta was 6, let's go from -6 to 6. And in terms of the scale, you can just leave it at 1. And then we'll do the same for the y min and y max. We'll go from -6 to 6. Scale of 1. All right, now our windows should be all set. This sets up R. So let's grab that screenshot. Now we're in a position to look at the graph because we've got our window all set up nicely. So you can hit graph. Oh, we forgot to put in our function. Well, we're not going to see any graph. So let's come back here and put in 6 cosine theta. Again, you can hit this button right here. It will now produce a theta instead of an x. Now let's try hitting graph. Okay, we thought we'd see a circle. We see a football. So let's try to do zoom 5 z square. That should square up our window a little bit so that the same amount of space for an x is for y. It's not stretched out. Because remember, you have a screen that is not a square. So we will now just, I think I'll do a screenshot of this right here. We want Z5 as necessary. Good. And now we're going to want to do a table set because we want to produce this graph on paper. So let's hit second and then window to get our table set up. We will start it at 0 and we will go by tens. Again, I'll screenshot that for our notes. And now we'll go into our table. So we'll hit second, graph, see the table, and now we see all the table values from 0 to 100. And we're going to basically plot all these points. Okay, so I'll get these points into our notes as well, and we'll be all set to make this graph. Okay, so if you have your own graphing calculator, you're all set. You've got your points to plot from your table. If you're without a graphing calculator, I have placed the 36, or I guess it'll be 37 points in this screen so that you can copy down, you don't have to copy down the table, but you can get the theta and r values and plot them on a piece of polar graphing paper so that you can produce that graph. Okay, so pause the recording, plot all 37 of those points, play the recording when you're ready. I would recommend a colored pencil or colored pen when doing so. Now, when we work on the 100 degrees, once it gets past 90, it's a little tricky. So 100 degrees has a negative radius of -1, basically. So instead of going to 100, you're actually going to come out the other side to 280 and be at -1. So you got to really be careful here because the grid paper is a little small. Okay, now that I have those points plotted, I can make a curve. Got a little bumpy up in here, but you can see that that is the curve there. I can smooth it out. All right. So there's our circle, radius of 3, 6 cosine theta. The second curve I'd like you to sketch out is, or explore, is what happens when we have sine of theta. And what I'd like you to do is go back and visit Desmos. I would like you to turn off the cosine function, turn on r equals n sine theta, again, circle. I'd like you to jot down these questions. Okay, relationship between n and the radius, where's the circle tangent to, where's the center, and then what happens when n is positive, when n is negative. Write those down, play with this slider a little bit, and then jot down your observations in the form of those answers. Okay, so pause the recording, write those questions, and then get on Desmos and play a little bit. Okay, so hopefully you had enough time to play with those, and you paused and stuff. So as before, when n is 4, for example, the radius is 2. When n is a negative 6, say, the radius is 3. Okay, so it's the half of the absolute value of n. Now, normally we'll call this thing a, this coefficient here, just like in parabolas and sinusoids, but I had to do something different with Desmos. So we'll go 1/2 the absolute value of n. Where's it tangent to? Well, it seems like no matter what I do, it always touches this polar axis. And where's the center? Well, as we move n around a little bit, the center of the circle stays on the line, the vertical line, theta equals 90. And finally, what happens if n is positive? Where is that related to the polar axis, or the pole? Okay, so if we make n a positive number, it's above the polar axis. If n is a negative, it is below the polar axis. Okay, and like before, we could now proceed to graph something like r equals 6 sine theta by plotting points. You know, we can go into our graphing calculator, change this to a sine, and now we kind of know where we expect to see the graph, right? Above the polar axis because it's a positive value, and with a radius of 3. 1, 2, 3, there's our center. Okay, so we are not going to take the time right now to have you get all those points and plot all those points. If you have your own graphing calculator, you may certainly do that. Thanks for watching.